Hello, my name's Simone Auger. I am the incoming vice president for the Portland section. I just wanted to thank everyone for being here today, and we really appreciate you participating. We have great educational sessions coming up this year, so please keep tuned in and join us throughout the rest of the season. I'd like to introduce Ron Scott today. Hi, Ron. Ron is with Finelite. He's the area vice president for Canada and Western US. He's been in the industry for 25 years with a background in mechanical engineering. And I'm going to turn it over right away. So here you go. Thank you.
Hopefully you have me on the mic here. Is that okay? So thank you for the IES and everyone for coming to see this presentation. What I'm wanting to do is give you a bit of a background on a study that we're involved in with the Department of Energy, so the DOE, and I'll give you sort of some of the criteria and some of the thought that is going into this report that'll be coming out at the end of the year. I think early 2017 is when it is due to come out. So a bit of housekeeping on it, if this is working. Gotta love props. Try it now. So with your introductions, it was great to hear there's a couple of architects. So this is an AIA presentation. There is a sign-up sheet at the front. So if you need credits for the AIA, if you put your name and email address, and if you have your AIA number, we can send you a certificate. And if anyone else wants a certificate for this presentation, you can sign up on the sheet and we will email you a certificate for you so that you can submit for any other learning credits that you're looking for other societies. So what we're going to be going through, like I was telling you about, is in 2015, the Department of Energy initiated a project where they wanted to take a look at what the classroom of the future was going to be. And so they're taking a look at what new trends in learning, what is the requirement for the classroom, and all of us involved in the lighting industry, we've seen some of the changes in the lighting industry. So they're wanting to adapt to some of those new trends. And also with that new trends comes color changing, which starts getting to me maybe a little bit more human-centric lighting with the color changing, and also the way people are learning in the spaces. So what we're going to go through is we're going to identify what the DOE was looking at for the classroom of the future being, and we're going to talk about how that classroom is laid out and some of the performance goals and criteria that they were looking at in this report that's going to be coming out. And then we're going to talk about just the classroom performance and how everything is laid out. So the partners, obviously I said the DOE is the one partner. We'll talk about sort of how they laid out this program. But RTI, which is a research company, is doing a lot of the documentation within this report. PNNL is giving a lot of advice in the background on the report. Samsung's is the LED engine that we're using in the lighting system, and then also monitors within this classroom that I'm going to talk about that we mocked up. And then Finelite submitted to be the lighting manufacturer, and I'll talk about sort of a classroom that we have made in the space and what support we're doing within it. So let's just talk about lighting to start with. So we take a look at the structures of building a school. Schools are built for a long term, for a long lifespan. You can see obviously the steel structure. You're talking a long lifespan. But when you start looking at the interiors, you start looking at different lifespans. So your walls may have, so the surfaces on the walls may get redone every 20, 30 years. Furniture may be in a lot shorter time period. But we used to look at the lighting. That would be something that would be changed maybe every decade. But now with some of the life in lighting systems, that is changing. So that the life of the lighting system, now that we're using solid state lighting and getting lifetimes of L90, 100,000 hours and really long life out of that lighting system, you're now talking about almost the life of the lighting system being very similar to the structure of the building. We're also changed with the solid state lighting, and we've changed our form factor a lot. And I can use the lighting above us that in fluorescent days, we were constrained to that 4-foot lamp. So do you want that fixture in a 4-foot or an 8-foot? Where now you can see that we can do very custom lengths and can create different unique spaces within classrooms so that you can, what we like to nickname, tailor it to that space so that you can get creative within that space. So we're not constrained to that 4-foot, 8-foot dimension anymore. And then also too is we're getting a lot more architectural features within classrooms and the building. So obviously lighting adds to that architecture within that space. It sort of helps with the daylight and matching to that space. And a lot of the times we created spaces over the years that maybe were cave-like experiences where if you get lighting on surfaces, especially if you got a lot of glazing where lighting is coming in, you can make that space feel a lot more livable within that space. So getting surface brightness on the space. So lighting has changed in the last couple of years. So these are a lot of the thoughts that they're putting into it. So now, as I was talking about the lighting system, we're actually talking decades for the lighting before we even need to think about maintenance. Lifetime of that. So we were talking about fluorescent lamps that basically every so many years you were going to have to be changing or relamping. And now with LED or solid state lighting, we're talking decades before we have to even consider the light loss within it. Obviously, in the LED, the solid state is a lot lower energy as well. So our energy platforms within the space has changed. And you also can, with some of the controls, when you start adding, you can start changing the intensity in areas. So you can change people's focus by, let's start lighting a whiteboard. Let's turn off for an AV mode. So we do have a lot more ability in changing the intensities. And now you add that we can start changing that color, the color spectrum within so I'm talking white. So do we want 2700 Kelvin, 6500 Kelvin? Do we want to change the way that space feels? And then also maybe task appropriate, depending on how, we'll talk a bit about sort of how the learning environment has changed, and we can change the way the lighting is for those tasks. We also will touch into a little bit of schools are changing for different age, so that if you're building a school for adolescents versus adult learning, those are different light levels. So potentially you might want to integrate controls so that you change for those different environments. And then potentially adding maybe even circadian rhythm to that space. And then if anyone's heard about a lot of the discussion of Internet of Things, a lot of the solid state lighting now, you can actually integrate it to building management or even beyond, so that you really have smart luminaires. And then in areas that require demand response. So those are all things that have changed over the last years, or have really sort of come on a lot faster in that changed our thoughts of the lighting systems. So we can start talking about future-proofing the lighting. You're always looking at the value of the lighting. So it's the cost of your lighting over how much it's being used. But now when we talk, that use is now in decades. So we can actually get better value out of lighting systems now. And then also if you do add potentially circadian rhythm or changing color temperatures in that space for different feel, and then also local control. So the teacher has control, and potentially the principal has control over the whole school, or whoever's in charge of the building. So now you're starting to talk about the lighting being equivalent to the structure in the building and being task appropriate. So multi-use different spaces. And we can start using that lighting to change people's behavior. Let's make everyone alert. Let's calm people, so that you can start using those different color temperatures. But let's just take a look at how classrooms have changed over the years. Learning is everywhere, so it's not just structured to your desks and that whiteboard anymore. A lot of the times learning's in all multiple spaces, and we have to light for that space. The way teachers are teaching a lot of the time is changing. So we're either teaching as a big group, or we may be telling people to work individually, or maybe even a combination of it. We're going to break into different groups. So the teachers in those spaces have spaces that needed to be adapted to, and then how do we adapt the lighting to that space? So the classroom has changed over the years. It's, I don't want to date myself too much, but it was pretty much a pencil and a desk in my days and a chalkboard. And then now you can, now we have iPads, surfaces that are, you're having that device face up, potentially going to the lighting system. So how do we change the lighting so that you don't get those reflections? Now we have smart boards, so that teachers are using smart boards or even just using TVs for presentation. So it's really changed the way we have to light in that space. I was talking about the day of chalkboards. So now we've advanced to whiteboards, but also now you may see in a lot of schools that they're using the paintable walls that are writable walls. So now you're not constrained to just that whiteboard. You actually have a larger space that could be that area that is going to be a teaching space where you need to change people's focus for that space. And again, going back to my desk, that it was a big thing if our classroom turned our desk 90 degrees in those days. And now people are moving throughout the spaces. The teacher wants to be able to move people into groups. And there are furniture systems that are coming out that are movable so that it can be moving throughout that day. So you have different spaces that we are going to be lighting. It's very expensive to build a school. And if you only are using that school from, let's say, 7 till 3:30, it's a big expense. So we need to, a lot of the schools are using it at night so that you're using it for community activities. Or you're starting to teach to different individuals. So that school is not just for youth learning, it is also for adult education. And obviously talking to the IES, you know that those are different light levels. So if you're designing to the aging eye, it's a lot higher light level. So that is where do we adapt the lighting system so that on those, at the night, maybe we have a higher light level for that learning environment. So getting into, so those are all things that were just at least considered in the changing classroom of the future. And now this is just taking a look at actually what the research is going to be going. So those were kind of the basis, but sort of here's what the documents of what the DOE was taking a look at. So the DOE created an illustrative of what they perceive the classroom of the future. So first of all, they're just looking at what the classroom is. So that you take a look at the front of the room, it would be a lecture space. And then there could be spaces that are different learning environments. So when this yellow area is, it's not really a desk, but it's a learning space. And then the space that we created, we also brought in some daylight so that we created a daylight zone within that space because most schools do have that. And then you can see that we have whiteboards and then also smart boards within the space and also at the back of the room. Taking a look, I was talking about the life cycle. The DOE took a look at the life of some of them. The way they're putting criteria on the life of some of the systems is they're looking at the windows and the walls have a 50-year life. But things that are on that wall have a 10-year life. So you can see one of the things is the monitors in the space. Who's changed their flat screen monitor in the last couple of things? So the Seahawks or whoever your fans are looks better. They are changing a lot quicker, and even the whiteboards do have a bit of a lifespan. So things on the wall, they looked at a 10-year lifespan for it. But I was talking about that adapting classroom. They also wanted the system adaptable so that if they rearrange that learning space, it could be groups throughout the space. It could change the focus in the room so that we all of a sudden are going in different areas. Or you can be breaking into small groups and medium groups. So these are all sort of, they wanted to think of that space that it was very adaptable, that it can change within the space. So the next thing is they set out some performance goals. So they wanted the teacher to have control of the intensity of the lighting, which is turning on and off whiteboards, changing the intensity of the space, but also changing the color in that space. So from different Kelvin temperatures, which I'll go through. We also wanted the space to work with energy savings with daylight and also maybe adapting to balancing for that daylight. And then they wanted the potential so that you can have central control. So a teacher has local control, but maybe the building manager or principal has local or central control of the whole space. And then obviously the performance of the luminaires. So we're looking at luminaire efficacy. They set out guidelines, which I'll go through. They also set out guidelines for flicker and the power quality within the system. And then also lifetime of the lighting system and color stability. And then obviously they set out, we're all used to seeing probably light levels within the space, but it was vertical and horizontal illuminations. So here's some of the data. So what they asked for, they said in a lecture, they wanted 40 foot candles average. If we're doing a discussion or doing some note taking, 30 foot candles. If I'm using a monitor up at the front, 5 foot candles within that space. And then if a presenter is at the whiteboard, it was 30 foot candles. So those were the general lighting guidelines, but they also wanted to give for the color temperature. So what they asked for was range from 2700 Kelvin to 6500 Kelvin, and then 2 intermediate set points. What we provided them with was 2700 and the 6500, but we also gave them 5 different set points and also manual control so that they could go to whichever output that they wanted for color temperature. So Finelite's part of it is that we took a look and we selected our LED manufacturer for it. So you have the raw LED chip. Now we took that LED chip and we put 2 chips, so a 2700 Kelvin chip and a 6500 Kelvin chip together, and we laid those out on an LED array. They're in multiple different form factors so that they fit in different luminaires. So that we built and tested different luminaires that could work within that space. And then we also built a plug and play control system so that it was very easy to set up and also to adapt in the system. And then we created the lighting output to meet the performance goals of the DOE. And then the big thing is in the back of our plant in Union City, just around the San Francisco Bay Area, we've actually built a classroom in the back of our facility. So they're bringing in educators, they're bringing in researchers, and they are bringing in, I think at some point they're going to be bringing students in, and they're asking people, how does this work? Would you use this? And they're giving feedback to us of what they like, what they would use. So it is a very versatile system. And then obviously when we built that classroom, we installed the luminaires and we measured, verified all the measurements to meet those guidelines. So RTI is kind of the checkpoint. So they took a look at our LED package information. Samsung gave us all our data, and then also we give them our data when we installed that in our luminaires, so that they looked at the LED package, also the LED array now when you put it together, and then the luminaire when you put the whole package together, and then as it works as a system and the whole room. So they're basically verifying all the results that we have. So if you look at the raw LED for the test, we have actually provided them with an 80 CRI and a 90 CRI chip. The raw chip, the efficacy of it is 167 lumens per watt. And then we're using 2 chips, like I said, a 2700 Kelvin chip and a 6500 Kelvin chip that is actually mixing together to get those color temperatures in between. And we provided them with all the LM80 data, so all the data within that raw chip. So now you take that LED package and you have to actually put it together on an LED array. But you can see we're using that 2700 Kelvin chip and a 6500 Kelvin chip. And you can see the spectral quality very good. And when you mix those two, you can change the intensity to mix them to get anywhere in the middle. So this is showing you a 3500 Kelvin 2 source. So it's a mix of those 2 chips to make 3500 Kelvin. And if you compare, this is 2 source, so we mixed those 2 LEDs with intensity to get 3500 Kelvin. And if I compare that to if you purchased a 3500 Kelvin chip, you can see it has almost identical spectrum between the two. And then if you look at the photometry of the luminaire, it's actually almost identical between that 2 source versus just having a 1 LED source. Now, one thing to note, if anyone knows LED chips, The 6500 Kelvin chip is a little more efficient or efficacious than a 2700 Kelvin chip. So if you take a look at our luminaire, when we mix it together at 3500 Kelvin, if we use that as our baseline, if we go up to 6500 Kelvin, we have about 3% more lumens coming out of that luminaire if we put the exact same drive current. But if you put that exact same drive current to a 2700 Kelvin chip, you get about 3% less lumens out of those luminaires. So it does change the lumen output if you change your color temperature, but it's very, very small amount. And then we just looked at the color stability, which we provided them with them. So it's the TM30 data. So if anyone's seen these charts before, this is the baseline comparison, and then the red is what the actual color performance of the 2700 Kelvin chip, the 6500 Kelvin chip, and then the mix of those two chips. So right now, the research we have taken a look at what the luminaire performance has. They have taken a look at all the lumen maintenance. The efficacy of the luminaires is over 120 lumens per watt. And in the test, we're using all different styles of luminaires. We're using recessed products, we're using wall wash products, and then we're also using direct indirect products as well in that space. Some of the things we're looking at too is color stability and also the life of the LEDs. So we're stressing the LEDs to take a look at what the life, and you can see at the bottom the L90, 100,000 hours. So if everyone is familiar with that, is in 100,000 hours of operation, you've only lost 10% of your light output. So that's where the L90 is. So really long life out of the system that we are providing them with. And then this is an overview of sort of the power of control that we've given them in this space. So we do have a plug-and-play system so that it just plugs together for DMX control, and you can plug together daylight sensors, occupancy sensors to build that classroom lighting. It is developed in a way that we can give them 3 zones of daylight so that you can have a primary zone, a secondary zone, and then the third zone is an interior zone that doesn't get affected by the daylight. So those are the 3 daylighting zones. So hence you have 2 daylight sensors, and then you potentially have an occupancy sensor in that. And then we are giving them a teacher station that the teacher can locally control the intensity and control the color temperature. But you can also bring out central control so that they can control all of those classrooms within the space. And then we've also added the ability that the teacher can use an app so that they can control the lighting system from their phone as they move around the space. So just taking a look at, everyone's probably used to seeing all different light levels in a space being the IES, but they're also looking at the different preferences of color temperatures so that the teachers may prefer 3500 Kelvin, but the students may actually say, no, this is what their preference is, 3825 Kelvin, so different spaces. You may find even that a different teacher will like a different space or a different color temperature. I think one of the big things is that we're going to be giving them the tools so that they can try and adapt to their learning space. But when you start looking at different spaces, so now we talked about the aging eye, we've actually brought the light levels up higher so that you can see in the space we have 60-foot candles in some spaces. And then also if you want to go to an audio-visual mode, so that we want to have contrast so that that monitor shows up a lot better, or projection TV. So, but we still want to have a low enough light level that people can take notes in the space. Because who ran the film in high school and fell asleep during when the teacher was doing a film? You still want to keep that light level on a little bit so that everyone is attention. But also too, is they're also finding that maybe when they're using the whiteboard, we'll change the color temperature to get people's attention. So we're changing their attention by using different color temperatures. What about balancing it with daylight so that we can match what's going on within the daylight? One thing within the space, so this is a picture of the actual space that we have made. For the daylight, so that we can control the daylight, we've actually made light boxes so that we can turn it on and off, and also change the intensity to emulate the daylight within that so that it's controlled. But then also maybe we'll talk about alertness. Does anyone have high school students? And when you first get them up in the morning to try and go to school, they're not exactly the most energetic people. So maybe you actually start off first thing in the morning and get them in alert mode and put it on. One little segue on that too is when we bring teachers and educators into the space, we've talked to them about, some teachers don't know what a 6500 Kelvin is, so that maybe we'll call it alert. But then some teachers came in and said, I don't want to have alert. To me, an alert button is calling for help. So they're giving us feedback on even maybe the wording that we should use on the control system. And then potentially come back from break or recess and everyone's excited. So maybe you want to actually change the feel of that space. So let's go to 2700 Kelvins and change or calm that space. So they're looking at using those different color temperatures to change the feel of that environment and sort of try and influence people in that space, so that you can see the difference in those two spaces between the maximum, what's at least termed right now, alertness versus calm. And then also we're taking a look at just, obviously, the blue component can affect what the circadian rhythm, but it also affects your scotopic vision and your photopic vision. So the way you perceive in that space at the different sort of outputs of different color temperatures. So that is basically just giving you an overview of sort of what the project is, what they're taking a look at. So what I've been told is, I'm not one of the ones working on this project, but I do come in, our founder, Terry Clark, and some of our researchers are actually dedicated to the project, that they have to work on it for so many hours and bringing people in. So there is still some work to be done before the report comes out, but I think it's going to be the end of the year or early 2017 when the reports can be released by RTI. So RTI is still doing a lot of the testing on the luminaires themselves, still carrying on a lot of focus groups. So they're bringing focus groups through this classroom environment, and they're trying all different situations within that. And then, like I said about that alert mode, we are potentially giving them different control panels so that they want to have it simple enough that we can train a teacher how to use it. But then if a substitute teacher comes in, there's enough intuition in that system that they can just start taking it over. They don't have to be trained to be using it. And then obviously the documenting and then publishing the final report. So this is a report that is in progress right now. So that's basically an overview of all that report. I guess question? Are
you guys testing like the fade times? I mean, are you guys doing that? Like come in after lunch, 27 fades?
Yeah, so the question is just if we're testing the fade rates. I'm not entirely sure, but I know what you're getting at. You don't want to have a disco effect that we're going from 2700 Kelvin to 6500 Kelvin. Is that what you're talking about? I know our system, we do have a built-in fades that even if you go through one, it does a few seconds to go through, but I'm not sure if they're testing 3 seconds versus 10 seconds. I'm not entirely sure about that, but I know there is right now a built-in ramp between the different color temperatures. There, yes, I did. It was on the front. It didn't really. So he was asking if there's task lighting on the whiteboards. So in the layout, there is wall washers on the whiteboards. And interesting, maybe if I add to that, we actually gave them the ability that we have the classroom in one color and we actually have the whiteboards in a different color temperature, just for them to try, does it help putting it at 6500 Kelvin on the whiteboard and it's 3500 in this space? And it's kind of one of those things, I don't think that will happen, but we gave them enough control so that they could test that.
My other question is, what was the classroom that you built in? And the reason I'm asking is now you're putting in 2 LED chips, some of which are working sometimes not. What is the overall?
I think I actually probably jumped through it, but I think the overall general is about 0.4 watts per square foot. And even though we're using 2 chips, we're using a driver that we're always putting the same power to. So we're putting We're always putting out, if everyone knows drive currents, I'm just going to throw a number out there that we're putting 100 milliamp drive current, but it could be going just to one LED, or it's 50 milliamps to the two LEDs. So it's always using the same power. And that is why I brought up the lumens output changes by the color temperature just a little bit, because that's that exact same drive current. I think you had a booming voice enough that...
On the control that the teacher has,
Yeah.
is there an indication of the actual color temperature that you're going to?
Right now there is, and actually I can...
And if so, how are you determining that?
It's within our control system, that at least in our system, I do have a kit of our system here that I can plug in, and if anyone wants to come up at the end, they can take a look. That is where I can show you our control right now, where if you change the color temperature, and even if you use the Bluetooth app, it'll actually show you what it is, 38, 25, so it's within 25 increments of Kelvin temperature. But that's also where some of the teachers have looked at that and go, I don't know what 38, 25 is, just call that calm, or call that to a certain number. So that is something that we may come out with, here's one control panel, but here's the one to use in schools that just have presets.
Seems like you could put a little description along with, that as you go up, this is cooler, calmer.
You could.
Or warmer.
And there is a button to actually change to go up and down manually. But it's one of those things, you also want to keep it as clean as possible. You don't want to have 3,500 Kelvin and then put the text midpoint. So you'll have a control panel that has a big long description. So those are all things that we're looking at. And there may be potentially, like I said, maybe 2 different panels that you could choose from.
Early on, you mentioned that the whiteboards and equipment was estimated to have a 10-year life. Did that 10-year life include financing replacements, which often is very difficult?
I think I don't know if they're actually putting sort of a budget for every 10 years you have to account for so many thousands of dollars of upgrades. I don't think they have put that. It's just a case of they are putting just sort of the time cycle on whiteboards, things hanging on walls are 10 years. I don't think they're putting a cost to it, as far as I know. Naomi?
Okay, I'm going to raise a controversial issue that I just learned about a few weeks ago. There was evidently a live classroom test of color changing luminaires done in Germany. And the manufacturer ended up in a lawsuit over it. And the conclusion was that it was inappropriate to change color over the course of the day in order to manipulate the children's mood and hormones. So I'm sort of stuck in this, I'm kind of thinking, yeah, this is a cool idea to wake up kids, but is there something unethical about that?
I'm not familiar with that lawsuit, but I know I have to be careful in saying this will help your circadian rhythm. There is no facts to that, or this will affect your circadian rhythm. I think it can basically mimic your circadian rhythm, but some of the research that is out there there needs to be a lot more research on how it is affecting people. There are some, I'm going to say, static systems that they have put in schools that were putting children under 5,000 Kelvin for their entire day. And I know there has been some studies that they go home and they are too alert, or they will not calm down when they go home. That's what I've heard. And that is where you want to maybe have it adaptable so that it will change throughout the day. I'll go over here. Do you have a question or no? Oh,
I was
sorry.
just going to add on to that because I've been to a couple of the CCT changing school kind of seminars, and I like to liken it to this, even though there's no proof out there yet. But I would think that if your parent came to you and you were a teacher and you were like, you gave them how much coffee at 3 p.m.? If we're putting this really blue light for a test at 1:30 or 2 o'clock in the afternoon, I think it's, if we give it to them at 9 a.m., that's more like circadian rhythms that may not affect. You have half-life or whatever it is to get out of their system until they go to bed. But if the teachers are like, oh, this is alert mode, we have a test, I'm going to put this on. And like you said, the static classrooms that have the 5,000 K all day long, I think it's very much akin to giving these parents find out that their kids are getting like a whole huge dose of sugar, a huge dose of caffeine late in the afternoon, and they have to try to put them to bed. So I just kind of wonder, how is the DOE, have they thought of that? Is that in the discussion? Is there concern about giving the teachers that kind of control?
I'm not entirely sure, but it's within at least this environment. It is discussions, I know, for other studies of just sort of how much and the amount of dosage sort of within that time. But I'm not too sure within this study if they're going to be doing that.
We have a question online too.
It's just one of those things of, we now have the power. It's one of those tools that you have in your tool belt that you can give to those educators. We may have to keep an eye, or somebody may have to put a guideline sort of at maybe the amount of time in certain modes is something that they might be looking at. But it's definitely something that I think people are looking at, that it can help learning at some point, but you have to be careful of the health benefits on the other side of it.
Kyle, you want to unmute the online person?
Thank you. What's been the general feedback with using 6,500 Kelvin classroom?
The general feedback, I haven't been there personally for the focus groups. I've only been when I bring in sort of clients and the lighting group within it. Usually it is a stimulant. When you walk into that space, it does sort of wake you up in that space. It's also too, a lot of the lighting professionals take a look at 6,500 and it's too blue for them in that space, in the way, at least appearance. So it's at least feedback. I think it would be very rare to go to that high extreme.
I just had one comment, and that is primarily for all the architects in the room, and it's that those rooms were very, very white. And I was taught that you pick the color temperature of the source to match the environment. That's a unique challenge, right? It looks the way it's supposed to. And I totally agree with you, Naomi, that I think there's way too much danger of, we do this in hospitals and things to shift circadian rhythm. And I don't know, I was going to ask Robert, do you know how long it takes for exposure to the sun, or does anybody in here to set circadian rhythm during the day? Is it? Okay. So you could have it set for the wrong temperature for hours during a day and screw up a lot of little kids. Further.
Or if not, I can repeat.
Okay. So do your controllers override the daylight sensors? I mean, the whole questioning that's going on recently with this is, are we manipulating behavior, or are we trying to bring some of the natural lighting into the room and make the indoor environment respond to the outdoor environment? And I think that that's the way it could be used more effectively. I had some feedback directly from a school in Des Moines that has used this in the special needs classroom. And those teachers really like having that tool to be able to, in extreme behavioral situations, to be able to change it. Otherwise, aren't we just trying to make the room feel like it's naturally lit?
It's just maybe to clarify, there is two different things. When you were talking daylight sensors, the daylight sensors we're putting in that space are looking at the intensity. So they're changing the output of the luminaires. They're not changing the color temperature. So it's not color. The daylight sensors are your traditional IC 40-foot candles, so I will dim the first row. It's not changing the color temperature.
So you're saying the daylight zone is not affected by the controller that you have that is changing the color temperature?
It is changing the intensity of those luminaires, so that if I set the entire space to 70% output, if that daylight sensor sees more light, it will actually put that one lower to balance that. So it's electric load that it's changing, not color temperature, if you get what I'm meaning. So the color temperature would be, so you can change, you cannot override the intensity of those daylight sensors, but you can change the color temperature.
Yeah, I understand how it works. I'm just saying that if you've got a daylight zone that isn't responding to the controller on the wall that's changing the color of the lights in the room, you've got two different color temperatures going on in the room.
No, we're doing the same color temperature throughout that space. So the way we set it up, we have the color temperature as for the ambient general lighting, it's always the same color temperature, so it's one color zone. I brought up the fact that we did do the wall washers with a different color temperature so that they could independently, they could at least test that to see what it looked like for 6,500 Kelvin on a whiteboard when the space is 3,500 Kelvin. Does that change your sort of perception of that or change your focus?
I think what she was saying maybe is that the daylight will impact the color temperature of the room because it's mixing, yeah.
It will, yeah. It's hard to change, hard to override the sun.
Okay, I didn't mean to throw a rock into the puddle. Well, maybe I did. But here's some questions that come up. I understand why you would want to change light levels and change color, because when I went to first grade, there was no kindergarten where I was living. We had nap time on the floor, and the teacher turned off the lights during nap time. So was she manipulating our circadian rhythms? You bet your socks she was. And she didn't know that, but she was doing the right thing, I think, to calm us down. So is this just another way to turn off the overhead lights in perhaps a way that's more accommodating? But then there's another issue of whether having changeable lighting is better or worse than fixed lighting. There are some people who will say it's worse for kids to be under fixed lighting all day. You know, pick a number, 3,500 K. The quandary is we just don't know. We don't know what's best for those kids. I don't think.
No, and it is something that the solid state world has given us this power now. So for years, we had to pick a fluorescent lamp. Is this 3,500 Kelvin, 4,000 Kelvin? And to change that environment was quite a process. You had to change all the luminaires versus actually going and hitting a button and changing the way that space feels. So it is, and that's where I throw it out of that tool in everybody's tool belt that you can potentially use it now in spaces like that. It's one of those things that you have to balance the point of you can change people's feel and focus in that space, but I think you do have to be conscious that if you put them in a certain environment for a certain amount of time, that you can be affecting their sort of circadian. Question back there?
Yeah, I had I saw an article from Korea, South Korea, about a study on doing exactly that, on changing the colors in the rooms, and they wanted to see if certain colors would calm the students down at certain times, and if certain colors would improve test grades. So, and I think in that particular study, they couldn't make a definitive conclusion from it, but it's probably something that's certainly being studied elsewhere, but it's obviously not in your study. But yeah, but I don't think yours is geared toward that kind of.
No, it is not sort of geared in that way right now.
Okay. Well, we'll wait and see what they all say.
Just a quick question on your chip.
Yep.
Was that the phosphor overlaid chip or an RGB chip? Do you know?
It's phosphor overlay chip, so it is not RGB.
Thank you.
So if that's it, I thank you for your time. I'm going to be around if you want to take a look. If you haven't seen a white color changing luminaire, oh, Barb's got the mic, careful.
No, one quick question. What's the operational definition of future?
Oh, jeez. It's, I guess, myself being, all of us being in the lighting industry, I think we've seen some of the most changes we have in the last 10 years with LED. So it's, I guess I wasn't the one who came up with the term for that future classroom, but it is what we perceive the future classroom to be, but I don't know what the time on that one is. So that's, yeah. Yeah. Okay, thank you.